Let's solve the next one. Look at this one. Find the sum of n terms of the sequence 8, 88, 888, then 4 8s like this, correct? Now, see, very clearly this is not in GP because there is no common ratio at all. But can we convert it into a GP? That is the main question. All right. So here in the sixth question, what we'll do, you have 8, 88, 888, so on and so forth. So 8, 8, 8, 8, 8, 8, so on. And this 8888 is going to be n number of times. Correct? N terms are there. Now what we'll do is that we can convert this into a GP. That is the whole point. Okay, so to convert this into a GP, so what we do now is we divide the entire thing by 8. Okay, so when you divide, of course, you can't just divide and leave it. You also have to multiply. Correct? So first thing what we'll do, we can write this as 8 into 1. The next one is 11, 1, 1, 1, so on and so forth. Isn't it? Now we multiply by 9. That means, so we can write this as 8 into 9, 99, 999, so on and so forth. But you can't just multiply, you also have to divide. Isn't it? Because if you look at it, if you simplify this, you're going to get the question same question back, correct? Now this can be written in terms of GP. So what we'll do now is 8 by 9, keep it as it is, into 9 can be written as 10 minus 1, next 10 square minus 1, next 10 cube minus 1, so on and so forth till 10 power n minus 1. Correct? But the question, look at this, find the sum to n terms. Since it's a sum, what do we write? Instead of a comma, we write a plus, write a plus, write a plus, write a plus, so on and so forth. Correct? The summation is what is required. Now, we'll take the positive term separately, the negative term separately. In the sense, the 10, 10 square, 10 cube, all those things, you take that separately. Minus 1, minus 1, minus 1, minus 1, minus 1, that separately. Fair enough? What you will get is S is equal to 8 by 9 into 10 power 1 plus 10 square plus 10 cube, so on and so forth till 10 power n minus of 1 plus 1 plus 1 plus 1 plus 1. Okay, this one. So this is what we are going to get. See, 10, 10 square, 10 cube, that's a GP, isn't it? So we have 8 by 9, 8 by 9 into, what is the common ratio? It's 10. What is A value? 10. Isn't it? And since common ratio is 10, R is greater than 1. Right? So you can use the formula Sn is equal to A into R power n minus 1 divided by R minus 1. So if you substitute, you're going to get 10 into 10 to the power of n minus 1 divided by 9, which is 10 minus 1. Minus 1 into 1 into 1 into 1. So you have, there are n number of terms which are there, correct? Or you can say n times we have 1, which is nothing but n. Correct? See, you can either simplify this by taking LCM, or you can just keep this as it is as sum to n terms of the GP. Clear? So this you can write it as the final answer, or you can simplify and write it also. Fine. So this we can conclude saying that this 8 by 9 into 10 into 10 to the power of n minus 1 by 9 minus n. This is the sum to n terms of question number 6. Okay, let's move on to the 7th one. Now let's solve the 7th one. See, 7th question, the condition is what? 4 the numbers, you have to find the 4 numbers forming a GP in which the third term is greater than the first term by 9, second term is greater than the fourth term by 18. Let's first write the equation. So what we have now, third term is first term plus 9, and the next one is the second term is fourth term plus 18, correct? Now AR square is equal to A plus 9, the first equation. Next one is AR is equal to AR cube plus 18. Now take the A to the LHS and that AR cube to the LHS, so that you have one particular equation in terms of A and R. That means here you get AR square minus A is equal to 9, and in this case AR minus AR cube is equal to 18. Alright, take A common. A into R square minus 1 is equal to 9. Here AR into 1 minus R square is equal to 18. Isn't it? Now divide one by the other, because when you divide, A gets cancelled. One of the R's will also get cancelled, isn't it? Now what we are going to do is you are going to do AR into 1 minus R square divided by A into, see, you can do R square minus 1, or we can do 1 minus R square, but change the 9 to minus 9, that's all. That means this becomes 18 divided by negative 9, correct? A and A gets cancelled, this gets cancelled, negative 2. So R value becomes minus 2, isn't it? See, since R is minus 2, we can substitute this in this equation, the first equation, taking R as minus 2, and we can get the value of A, right? So once you do that, you're gonna get A into R square minus 1, that's 4 minus 1, 3, is equal to 9. So A value is 3. 4 numbers, AR, AR square, AR cube, isn't it? And the value of A is 3 and the value of R is negative 2. That means the 4 numbers, you can tell. So let's write it down here itself. The 4 numbers, the first number is 3. The next one is going to be minus 3 by 2. Next one is 3 by 4. Next one is minus 3 by 8. So these are the 4 numbers which are in AP. So these are the 4 numbers which are in GP. Fine. Let's do the 8th one now. See the 8th one. What do we have here? If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square is equal to AB whole power n, correct? Alright, so what we are going to do, so we have A to be the first term, correct? And we have AR power n minus 1 is B, because that's the last term. Now what we are doing, we are going to do P. See, P is what? The product of n terms. That means P value is nothing but A into AR square till AR to the power n minus 1. Correct? Or you can say till B. That's the case. But in this case, what we'll do, P is equal to, see, you can do one thing. You can split two things. You can do A in one side and R in one more side. That means A till n number of times. So repeated multiplication is nothing but an exponent. So you can call this as A to the power of n. Then R square, R cube till R to the power of n minus 1, which you can write it as R to the power of 1 plus 2 plus 3 plus so on and so forth till n minus 1. Correct? Now remember, we are looking at till n minus 1. Now A to the power of n, keep it aside. we'll just consider that r to the power 1 plus 2 plus 3 till n minus 1. The reason why we are considering only that, because see, if you look at the power, isn't this an arithmetic progression? Isn't it an AP? 1, 2, 3, 4, so on and so forth till n minus 1. Now, if you take that, we can actually calculate the sum to n terms. But if you look at this, if you look at 1, 2, 3, see, that's nothing but a value is 1, d value is 1. We can calculate what is the sum to n terms, isn't it? So in this case, first and foremost, what we'll do, we'll take the AP. So our AP is 1, 2, 3, so on and so forth till n minus 1. Correct? Now what you have is that a value is 1, d value is 1, but n number of terms. Instead of that, you have n minus 1 number of terms. Correct? So what you're going to have is Sn or Sn minus 1 in this case. N minus 1 by 2 into 2 plus n minus 1 minus 1 into 1. D value is 1 anyway. So what do you get now? N minus 1 by 2 into 2 plus n minus 2. So we got n into n minus 1 divided by 2. Correct? This is the sum to n minus 1 terms. Now we are going to substitute this in the r power. That means you have the product p is equal to a power n into r to the power of n into n minus 1 divided by 2. Got it? Square on both the sides. See, when you square, you are going to get p square is equal to a to the power of 2n into r to the power of n into n minus 1. Correct? Or you can write the same thing as p square is equal to, see, you can write this as a square into r power n minus 1 whole to the power of n. Split this. That is p square is equal to a into into r power n minus 1 whole power n. But what is ar to the power n minus 1? Look at this, ar power n minus 1 is b. So we can write p square is equal to, see, p square is equal to ab whole power n. P square is ab whole power n, which is nothing but what we are trying to prove. So what do we get? P square is equal to ab whole to the power of n. Clear? So this is the answer for the 8th one. More like an answer, it's a proof. Correct? Let's do the next one. Look at the 9th one. The number of bacteria in a certain culture doubles every hour. That means what is our common ratio? 2. Correct? So we'll just write it down. R value is 2 because it's doubling every hour. If there were 30 bacteria present in the culture originally, that means A value is 30. How many bacteria will be present at the end of 2nd hour, 4th hour and nth hour? Right? So first we need to calculate for 2nd hour. See, originally it is 30. Correct? A value is 30, R value is 2. Now they're asking you to calculate T2. T2 is nothing but AR. That means 30 into 2, which is 60. So at the end of 2nd hour, we have 60 bacteria. Now we'll do the same thing for the 4th hour. That is T4. See, T4 is going to be AR cube, which is 30 into 2 cube. 30 into 80, which is equal to 240. So at the end of 4th hour, we are going to have 240 bacteria in the sample, or you can say in the culture. Now the nth hour, Tn, AR power n minus 1, 30 into 2 power n minus 1, or we can also write this as 30 into 2 power n divided by 2, correct? Or 15 into 2 to the power of n. This is going to be the nth hour number of bacteria. Clear? So this is the answer for the ninth one, or these are the answers because there are 3 answers. That's fair enough. Now let's do the 10th one. Look at the 10th one. If AM and GM are the roots of the quadratic equation are 8 and 5 respectively, obtain the quadratic equation. In the sense, the arithmetic mean is 8, the geometric mean is 5, correct? Or a plus b divided by 2 is equal to 8 and root of ab is equal to 5, correct? So a plus b is equal to 16 and ab is equal to 25. Make sense? Quite simple to understand. Now, when we talk about a quadratic equation, how do we write it? We write it as k into x square minus of a plus b into x plus ab, correct? Directly substitute. See, when you substitute, a plus b is 16, ab is 25, isn't it? So, what we can write, therefore, the equation is k into x square minus 16x plus 25 is equal to 0. Alright, so plus 25 is equal to 0. This basically gives us the quadratic equation with arithmetic mean and geometric mean as the roots. Fair enough? So these are certain type of questions based on AP, GP, AM and GM. Clear? Now in the next video, we are going to look at the next part.